As we begin our second video, we're trying to find the radius if the arc length is 58.25 units. So on this circle, because the central angle given was this major arc, this 320, that's telling us this is what we're looking for, this arc. They told us it's 58.25 units long, so it could be centimeters, it could be feet. They didn't really give us a unit. We're trying to find the length of this radius, though. Before we look too close into that, I want to go back to the arc length formula. And we can say this whole thing equals whatever our arc length is. Okay, take theta, that central angle, times pi over 180. Take all of that times the radius, and you'll get your arc length. Okay? From that formula, if you just multiply theta times pi and call it one fraction, we'd have theta times pi all over 180 times the radius. That would all equal the arc length. From here, we can simplify this equation a little bit more. We can multiply both sides by 180, and that would help us get rid of this piece here. So what would our equation say then? We'd have 180 times the arc length, L, equals theta times pi times the radius. Okay, so that simplified it a little bit for us. From here, we can divide it by theta times pi. So if you want, you think about it as first you divide theta, then you divide pi, but it's going to do the same thing. We're dividing both sides by theta times pi. And when we do that, this side we just have the radius left over. This side we have 180 times the arc length, all divided by theta times pi. So this is the formula we're going to use to find our radius. Okay? Since we know each of these pieces, we know the arc length and we know theta, we can find our radius now. We just plug everything in, 180 instead of times L, we know that it's 58.25, so it's 180 times 58.25 on top. Instead of theta times pi, we know our theta, this angle, is 320, so 320 times pi, that'll all equal our radius. From there, we would just simplify each of those pieces on top and on bottom. We multiply it out, 180 times 58.25 becomes 10,485. 320 pi is approximately 1005.3. So we have this fraction then, this one over this, equals our radius. And if we were to carry that through, then that means that our radius is about 10.42. Again, whether that means centimeters or feet, whatever unit it is, they didn't tell us, but R is going to be about 10.42. Next few examples have to do with the area of a sector. So a sector is just kind of a fraction or a piece of the circle. So in this example, you can kind of see how it's this piece right here of the whole circle. And if this central angle is 120 and the whole thing is 360, it kind of helps us see that this piece right here, this is 1/3 of the whole circle. And it makes sense because 120 is 1/3 of 360. So how would we find just the area of just this 1/3 piece? Well, we do the area of the circle, this pi times r squared, and then we multiply it by the fraction of the circle. So whatever this degree is over 360. So again, in this specific case, if we look at this example, 120 over 360, that's going to reduce to 1/3. So this is 1/3 of the area of the circle. So we just plug everything in. We say pi times, instead of r squared, we know that our radius is 6 centimeters. So pi times 6 squared. Instead of looking for the whole triangle, we want only 1/3 of it, or more specifically 120/360ths of it. But that will reduce to 1/3. So after we simplify a little bit, 6 squared is 36. 120 over 360 is 1/3. 1/3 of 36 is 12, so we have pi times 12. So in its simplest form, we can either say that it's 12 pi centimeters, to be the area of that one, or 37.69 centimeters. And because this is an area, it should be centimeters squared. And that would be our area just of this sector, not of the whole circle, just this 1/3 of it. Arc-chord congruency theorem. In the same circle or in congruent circles, so remember two circles that would have the same radius length, two minor arcs are congruent if and only if their corresponding chords are congruent. So this length, arc length C to D, is the same as B to A only if this straight line, I can use an actual straight line to do it, A to B is the same as D to C. And the other way around, if A to B is the same as D to C, then this arc has to be the same as this arc. Okay, so it shouldn't be too terribly difficult. Let's look at an example of how that works. We have two different circles here, and we are going to assume that these two circles are congruent to each other. If this arc length, whoops, didn't mean to click that. If this arc length A to B is the same as this arc length C to D, then that would tell us that this chord A to B has to be the same as this chord C to D, which means we can set up the equation 7x minus 2 is the same as 5x plus 6, or 7x minus 2 equals 5x plus 6. From there, how would we solve that? Well, we can subtract 5x from both sides, and we would get 7x minus 2 equals 6. Add 2 to both sides, and we would get 2x equals 8. And divide by that 2, and in the end we would just have x equals 4. So that would be our way to solve for x. And that'll wrap it up for our second lesson.